I graduated college in December of 1991, and I got a job at a GM division called Delco Electronics. It later became Delphi. And I get into my office and I sit down, and this is in January of 1992, and the guy next to me is designing a robot for this game that drives on corn kernels. So that was the first year's game, and I was 22. So that was a few years ago. I'm 40 now. So that was my first introduction to knowing what U.S. First, or that's what it was called then, what First was about. We were the team that my cube mate was on was one of 28 teams that started in First in 1992. It took me until 1998 to be on the team because I was young and selfish and didn't want to be a mentor yet, and did other things. And I got on because I wanted to compete with other engineers on other teams. I got on because I thought I was a pretty good designer, and I wanted to see how my designs compared with other engineers at NASA or Ford or Johnson & Johnson or whoever. So I thought I was pretty good. My job at Delphi was to be a robot designer for production lines. So my job every day, 8 hours a day, was designing robots. So I got decent at it. You do that every day, you get pretty good at those things. It turned out I got on the team in 1998, and the guy that I used to sit next to, he's now my boss. And so he let me do this stuff and play with these robots and mentor these kids. It took me about a year to realize that it's really not about competing and about seeing how I compare against the guys at NASA or wherever, but I stuck around because of the kids, and the kids gave me great feedback, and a lot of them are a lot smarter than I am. They just have less experience, and so they give me great feedback. So I've stayed involved for 13 years now. The adults on our team still do a lot of design. We work together, and the kids do design, we do design. We don't have any rules that say the adults can't design or can't build. We're one of the teams that the adults and kids work hand to hand. However, back in 92, 93, it was the adults only who designed, and actually a machine shop within the Delphi plant who built all the parts. So they would pretty much hand the robot over to the kids. The kids had some brainstorming input, and they saw this process, but it was really not as worthwhile back then. They saw the engineering process, but now, 19 years later, the kids are the ones building the most of the parts. They're the ones learning how to use the mill and the lathe and the bandsaw, and we just try to get stuff done as a team. And kids learn, we learn, and we work together. So it has changed over the years. Our team has changed from being this very high-resource GM/Delphi sponsored team. Now we're working out of our own shop, and we just have to get our own materials, and we make a robot. As a kid growing up, I have two uncles who are engineers. One of them worked at Jet Propulsion Laboratory, or JPL, out in Pasadena, and he did various projects. And another uncle worked in California also at Raytheon. And they would tell me what they did as engineers. And I liked math and science as a kid. I was getting good grades in those classes. So I thought, well, yeah, engineering might be for me. So I went to college to be a mechanical engineer, and that's what I got my degree in. And I also had a co-op job, and I realized what I liked and what I didn't like. So those two uncles were somewhat mentors. They got me interested in engineering. But really the two mentors that have helped me out the most in my life was actually my old boss at Delphi, the guy that designed the robot next to me in my first year. His name is Tim Garner, and he still is a judge at First Regionals, and he's the best engineer I've ever ran across. He's an expert in controls and linkages and machine design, and the best advice he gave me as an engineer at Delphi was not so much about engineering, it was more about entrepreneurship and life lessons. And when I left Delphi to make AndyMark, the company, he said, just do it. I mean, he was my boss, so he's in charge of my salary. So but he still encouraged me to make my own company, and that meant a lot to me. So he was more of a friend and a mentor than he was a boss. So while he is a great engineer, he's also a great friend. The second mentor that I've had as an engineer is my current business partner, Mark Coors, and he with our company, we're partners with Andy Baker, Mark Coors. So we share the company. I'm more the front man, and he's more of the behind-the-scenes engineer. But he taught me how to machine things. He taught me how to prototype things. He taught me how to do some more detailed engineering than I was used to doing. And I think he also taught me, probably the biggest thing that he taught me as a mentor was it's okay to take a risk, and it's okay to try out things, and don't think something won't work if you haven't tried it yet. So there'll often be something that the kids on the Technocats or another engineer will say, well, that won't work. Well, Mark will hear that as a challenge, and he'll say, oh, I'll get it to work. So he'll come up with this thing that'll work, and he'll bring it in to show the kids, and they'll be like, wow, that works. And then they'll take it from there, they'll put it on the robot, and they'll make a neat contraption. So that's the neat thing that Mark has taught me is take risks with your designs, and most things that you think might not work could work. We had a mentor a couple years ago, another engineer at Delphi. I think he was in charge of some products at Harley Davidson. So his day job was overseeing some product development for Harley Davidson as his customer. But he had a son on the team who was a real bright kid and got to be one of our robot drivers. But this mentor was also a 6-time world champion sprint car driver. So he was, I mean, sprint car racing is big in the Midwest. These are the smaller cars than Indy cars. They're like dirt track racing cars. But he won, I don't know, let's say national champion, but he was a big deal in racing. So he brought this racing experience into robot building. And so he changed how we designed our robots dramatically, made them a lot better quality, a lot more robust, and I think he taught everybody, the kids and the engineers that worked with him, how to build a really quality robot. And over the years working on that team, I've had many teammates, students and engineers who come through the team, and each one of those makes the team a little bit different. And in this case, Steve, the race car driver, really had a huge impact on the kids and the adults. There's many aspects to this that are very enjoyable. As a designer, I'm a designer, so designing a robot or designing the code for the robot or doing this thing on the robot that plays this game, it's a very risk-free design environment. Sure, okay, if something you design doesn't work, that's a risk you take, but you're not losing revenue, you're not launching a product that fails. You're designing something that plays a game that inspires kids, and you're designing with kids. So my point is it's a very low risk, high satisfaction design process, because you get to design new things very quickly. You get to try them out very quickly. So as a designer, that's appealing. More appealing yet is working with the kids. And you're working with these students. Maybe you work with a team of students as freshmen or sophomores, and then you show them what you do as an engineer, and then by the time they're juniors and seniors, they lead a design team. So maybe like this year, I worked on the drivetrain, but the kid I worked with last year on the drivetrain, he's now working on the arm. So we work together a little bit, but I showed him some things last year that he can do this year without as much leadership from me. And that's very rewarding to see these kids learn pretty quickly and become good designers themselves. I think the most rewarding experience is getting the feedback from the kids. I have countless times when I have kids come to me at the end of the season and say thank you. But our town is a small town. And I remember there was a couple kids that left the team their junior year about 10 years ago. One of them we didn't let travel to a regional because he didn't make grades. He was one of our best kids, but he didn't make grades, so we didn't let him travel to the regional. He needed to stay home to get his grades. And I saw him last year, and he said, you know, some of the best lessons I learned as a high school kid was what you guys taught me on Technocats. It wasn't so much the technical stuff, but it was my life lessons. I mean, you were tough with me. You were demanding. And he said, I thank you guys for that. I don't thank you for teaching me the technical stuff. I mean, that was great, but you were hard on me, and you were very demanding, and I appreciate that now. So to hear that 10 years later, it's kind of cool. I have three daughters, 13, 10, and 8, and they're all very smart. I mean, obviously they're the smartest kids in the world, right? Smartest and most beautiful. So I want the best for them, and I want to support them in whatever they want to do. And looking at my daughters, I've always tried to encourage girls on our team to become more and more involved. I think FIRST is a great tool for kids to be involved with who are girls. Mentors need to make sure the girls get the opportunities that the boys kind of jump in and do. I think that I'm generalizing, but the girls tend to stand back a little bit. The boys tend to jump in and break stuff, and that's kind of how it works. So, and the girls, I think, technically are as capable, but they're maybe just not as familiar with some of the tools, so they're a little more timid. Now, at the same time, we've had two different girls who have led our team in the past. We've had a girl welder who won state welding awards in the past. We've had teams where we've had one girl on the team. We've had teams when we have 15 girls on the team, and now we're more toward the 10 to 12 girls on the team, which is very healthy. The Girl Scouts has done a very good effort lately to get girls involved with FIRST Robotics and also FTC and FLL. So the Girl Scouts is a great organization that supports that. Women in high tech, Girls First, Society of Women Engineers, who all are paying attention to STEM education, and also girls in competitions like FIRST that are giving them opportunities that they haven't had maybe 20 years ago. I guess in the last 20 years, in my experience, it hasn't changed much in the workforce. I think in education it's changed. I'm hoping it's changed in education. But I worked for General Electric and I worked for General Motors, and those are two big companies that took on women in engineering early on. I think 30, 40 years ago they started hiring women in management and engineering, and they brought them up through their ranks pretty well, I think, from my experience from the two plants I worked in. And I've had female bosses, I've had female coworkers. Some were great, some were not so great, just like men. So it wasn't, I think in big companies, what I've noticed in my experience, they're treated fairly equally. I think the problems arise in smaller companies when you have not as diligent procedures and processes and maybe some protection. That's when things go awry. I think now, I'm hoping that guidance counselors and teachers in schools are giving girls the same opportunities that they're giving guys. And I think that's happening more and more. And so girls are getting the same opportunities. I have a small company, and there's two women that work with us. Now, they're my partner and I, that's our wives, but we also see them as very, very good team members in our little company. There's 7 of us that work in our company, and so our accounting manager is a woman, and our customer service and shipping manager is a woman. And as we hire new people, we'll definitely hire women.